Hello everyone, myself Geeta. In this video, we are going to look into integration by substitution. The problems, whatever we solved till now in the previous videos of integration, was in standard form, or we used trigonometric identities to bring it to the standard form of the integration formulas which we have, and then we integrated. Though it was not directly given, we used the formula of cos 2 theta, sin 2 theta, and we did few manipulation using these identities here and there wherever it's required. And I changed the problem in the way I can use my integration formulas. That is how we did it. What if it is not given in a standard form? What if I'm unable to use my trigonometric functions or trigonometric identities there to bring it to where I can use the integration? That is where we would be using the substitution method. So actually in this method, we are reducing it into a standard form by a proper substitution. And that is what is called as integration by substitution. Now here, if I have phi of x, which is a continuously, this phi of x, how it has to be? It has to be continuously differentiable function. It's very simple. Continuously differentiable function means I need to find my derivative, and the derivative what I find has to be continuous. That is what is continuously differentiable function means. So in that case, if I have integral f of phi of x has been given to me, and then followed by phi dash of x dx has been there, in that case, we substitute, the substitution happens, we substitute uh, for phi of x. Okay, so I'm going to consider phi of x is equal to t. In that case, what happens? Phi dash of x dx is gonna be equal to my dt. Actually, if you are unable to understand this, when I'm differentiating this, I would be getting phi dash of x. And you are differentiating it with respect to x, that means here you would be having dt by dx. But what I need is dt, so what is happening? The dx goes to the other side. So you are getting phi dash of x dx is equal to dt. This is how you are getting. And now your integration is getting reduced to f of t dt, which is again a standard form where I can go ahead and I can integrate. And later we substitute back the t value. That is what we do. Now here, in general, I'm gonna go ahead with few results. Like in the form. Let me just write the heading. Integral of the form. Integrals of the form. Integral f of ax plus b dx. So I have something of this form. What is this actually? If you observe how I'm having, this is in linear format. If I'm having something in a linear format, and before that if we have a constant, in that case, how we are going to proceed with our integration. So let me just start with theorem 1. There are 3 to 4 theorems which I will show you, from which you can just derive all those formulas and keep it in mind. But I'm not going to write all the formulas for you. Very simple. I'm just going to show you the method. So by observing it, if you find that pattern, apply this directly, you get your answer as it is without any trouble. So let me make it as theorem 1 here. If integral f of x dx is going to be equal to phi of x, then integral f of ax plus b dx is going to be equal to 1 by a phi of ax plus b. After integration, it is getting changed. That's how I have written. So now let me just give you a proof of it. So now what I'm going to do? I is equal to integral f of ax plus b dx. What I would be considering, let ax plus b be equal to t. Then when I differentiate it both sides with respect to x, When I do that, I would be getting a is equal to dt by dx, which implies a dx is going to be equal to dt. Done? So now let me go back and replace the things like substitution. Let me substitute. Now what I have, I is equal to integral f of t dx is nothing. Dx is getting replaced by dx is equal to dt divided by a. So that one I'm gonna write. Dx is getting replaced by dt by a. And we have 1 by a is a constant. Now when I integrate f of t, what I would be getting? I would be getting phi of t plus c is there. And then what is my t? It is nothing but phi of ax plus b plus c. So this is how we would be doing it. Now let me prove the second one. The formula which you guys are aware about. Integral x to the power n is equal to dx is equal to x to the power n plus 1 divided by n plus 1 plus c. You know about this formula. But I would be proving this one when I have ax plus b whole to the power n. So let me make it as theorem 2 for that one. Theorem 2. Prove that, I'm writing PT for prove that, integral ax plus b whole to the power n dx is equal to ax plus b whole to the power n plus 1 divided by n plus 1 into a plus c. And then mention n is not equal to minus 1 because the term here should not become not defined. That's the reason. Okay, now let's start our proof. What I'm gonna consider here is let ax plus b be equal to t. The one which is there in a linear format, I'm considering it. The one, how to go for substitution when I'm doing a problem, I will tell you a lot of clues there, how to identify which to substitute. And when we are doing problem, I will give you all the ideas, whichever I have. Based on that, you can go ahead with your substitution. That would always work. Okay, and for now, I'm considering ax plus b as a t. How did you make that as a choice? Only that was available, that's the reason. But when we have two or more terms also, I will tell you something which is there enclosed, protected type within a bracket. Always use that for substitution. That will definitely work for us. So now here, when I differentiate on both the sides, differentiate both the sides. With respect to x, when we do that, I get a dx is gonna be equal to dt. Now, what is my dx gonna be equal to? Dt divided by a. Now, let me just go ahead and substitute. Now, integral ax plus b whole to the power n dx is getting replaced by integral t to the power n dt by a after substitution. Okay, so everything is getting replaced. Now here what I would be having 1 by a is a constant and I would integrate t to the power n dt which is equal to 1 by a t to the power n plus 1 divided by n plus 1 and then plus c. What is my t here? T is nothing but ax plus b whole to the power n plus 1 divided by n plus 1 plus c. That's it. We have found out. So Wherever I'm having a linear format, and there I would be having like ax plus b format, like 2x plus 3 when you integrate, you would be getting 1 by 2 along with that. That is what is the thing which you need to observe here. Okay, so suppose I have, let me go ahead with an example for you to understand better. You have integral 5x plus 7 whole cube dx. This is what they are asking you to integrate. In that case, what you would be doing, you would be going for substitution, obviously. So let 5x plus 3 be equal to t. Then when I'm differentiating both the sides with respect to x, then I would be getting 5 dx is equal to dt. That means dx is equal to dt divided by 5. Done. And now let's go back to our problem. This one, which we considered I is equal to, let me write it as I is equal to, what is my 5x plus 7? Sorry, 5x plus 7. 5x plus 7 is nothing but t. So t whole cube dt divided by 5, which is gonna be 1 by 5 t to the power 4 by 4, which is gonna be 1 by 20 plus c is there. What is your t? T is nothing but 5x plus 7 whole to the power 4 plus c. Problem is done. But the same problem, what we are saying is, what I'm saying to you right now, when you observe that it is in the pattern of what 5x plus 7 the whole cube dx, when you're observing that it is in the form of linear format, in the format of ax plus b, you can go ahead with your integration directly and then write it as 5x plus 7 whole to the power 4 by 4 plus c, which is nothing but 1 by 20, 5x plus 7 whole to the power 4 plus c. So we got the same result here in two steps. Here in few steps, we have taken substitution t and all. What I'm saying is you can just go ahead and see the pattern, observe the pattern. If it is in the linear format, you can go ahead with your calculation directly, since we are aware about what format it is in. So that's why we are doing this. Okay. Next one, let me go for another proof using log. So theorem three. Let's see here. You would have learned this one earlier. We have learned integral 1 by x dx is equal to ln of mod x plus c. I have posted a separate video on this. In fact, so you can have a check with that video as well regarding this for more explanation why mod x. So now here, this one, if we have 1 divided by ax plus b, again, there's a linear format which has been given, a polynomial in a linear one. And then uh, dx has been provided. In that case, it's gonna be 1 by a ln of ax mod of ax plus b plus c. So now what we are doing here, as usual, I would be considering let ax plus b is equal to t in my substitution. And after that, I would be differentiating it both the sides with respect to x. When I do so, I would be getting a dx is equal to dt, and dx is getting replaced by dt by a. Now let me go ahead with my problem. I is equal to integral dx divided by ax plus b, and this is getting replaced by dt by a into t. So obviously 1 by a is a constant and integral dt by t is nothing but ln of mod t plus c. What is my t? T is nothing but ax plus b and then plus c. That's it. So this is how we would be doing in our substitution method. So only thing what you need to observe is whether the provided problem is in the format of ax plus b, is there within a bracket, whole to the power something, or as a 1 by ax plus b format. Suppose here I have 1 divided by 2x plus 3 I have. So in that case, integrate dx if the question has been given. Since it's a 1 mark type of questions, no need to take a time there. You can just write it as 1 by 2 ln of mod of 2x plus 3 plus 3. Directly you can write this. If you want, you can go with substitution. What you would be considering 2x plus 3 is equal to t, then 2 dx is equal to dt, then dx is equal to dt divided by 2, and then you would be proceeding with the problem. So instead, we can do it directly. That's the reason we are learning this now. Okay, now one last thing with the trigonometry, I wanted you to show that as well, whether this works with the trigonometry. The doubt would be there because it worked with x raised to the power of n plus 1 and by n plus 1, that is x raised to the power n formula, it worked integral, and it worked for logarithmic formula as well for under integration. Then let's look into theorem 4, where we would be having sine or cosine. So let's prove for sine. Prove that integral sine of ax plus b dx is equal to 1 by a cos of ax plus b plus c. So, as usual, the procedure, how it goes, I'm going to consider this as my LHS as I. And then I would be going with the substitution, the one which is there preserved inside the bracket. That is going to be my substitution. So let ax plus b is equal to t. And then when I differentiate both the sides with respect to x, I would be getting a dx is equal to dt. And then dx is equal to dt divided by a. So now let me proceed with my problem here after substitution. Let me substitute in my problem. So here I would be having sine ax plus b is nothing but t, dx is nothing but dt by a. Now 1 by a is a constant. I'm bringing it out. Then I would be having integral sine t dt. So when we integrate sine, what I would be getting is minus cos t plus c. So it's going to be minus 1 by a cos of what is the t? T is nothing but ax plus b plus c. So that's it. In the same way, the formula goes with e to the power ax plus b as well. I would be getting, so let me just write down the formulas. It would be helpful for you. Integral e to the power ax plus b dx has been given, means it's gonna be equal to 1 by a e to the power ax plus b plus c. And then if I have integral a to the power, let me change it as bx plus c dx if I have, it is gonna be 1 by b a to the power bx plus c divided by log log a plus c. And here I have to mention that a is greater than 0 and a is not equal to 1. So in the similar way, sine we have seen an integral cos of ax plus b if we have dx if we have, it is going to be equal to 1 by a. It's like a generalization I'm doing. You would have seen the pattern now and you would have understood. If something is there in the format of ax plus b, when it's a linear format, whole to the power something, uh, whatever it is, or sign of something might be there. In that case, that particular ax is there, then the coefficient of x will be coming in the denominator. So that's all about here. So I would be having here as 1 by a sine of ax plus b plus c. And then we have integral secant square of ax plus b dx. If we have, it is gonna be 1 by a tan of ax plus b plus c. And then similarly, if we have cosecant square ax plus b dx, if I have, I would be getting minus 1 by a cot of ax plus b plus c. So I think you are able to understand so how it works. Even I will give you one more formula which we have as secant of ax plus b into tan of ax plus b dx if we have. In that case, this is gonna be equal to 1 by a secant of ax plus b plus c. So even the other one, which is cosecant, also works in the same way. So I think you would have understood by now this pattern. So based on this pattern, we would be doing problems in the next video. Kindly watch the video, and if you really like it, I would like to subscribe the video and click on the bell icon which you have. Thank you very much.